So in this lesson, we're going to learn how to analyze and create histograms. And a histogram is a bar graph that shows frequency. Remember, frequency is how frequently or how often a data value occurs. There are three different types of histograms. The first one is uniform, and that's when all the bars are about the same height, which means all of the data is grouped pretty similarly. The second one is symmetric, and that's when the bars can be reflected across the line, so that histogram has bars that are higher in the middle and lower on the outside typically. A skewed histogram is when the bars are taller on one side and shorter on the other, so the data is heavy on one end and pretty light on the other. The histograms that we're going to be creating are a comparison histogram, and that's when you create two histograms on the same set of axes in order to compare data side by side. And a frequency table is what we need to create before we make our histogram. And histograms group data together, so you won't see a single data value, how frequently that occurs, because you may not have data values that repeat, but you can group the data value into different sets and then chart their frequency. So first we're going to analyze the shape of a few different histograms, and then we're going to explain what that means about the data in the histogram. So our first histogram is a survey of student TV habits. So as we look at the histogram, it's really tall in the first couple of bars and really short in that last bar. So this is an example of a skewed histogram. And what that means is the majority of the people surveyed watch TV from 0 to 11 hours per week. All right, so our next histogram is looking at the heights of black cherry trees. And what we notice is that the tallest bars are in the middle and the shorter bars are on the outside. So this is an example of a symmetric histogram. And what this tells us about the data is that it's actually what's called a normal curve. If you've ever seen, it's called a bell curve, higher in the middle and lower on the outside. IQs fall into a normal curve, heights tend to fall into a normal curve. So there are a lot of things that are, quote, normalized. And in this case, the heights of our black cherry trees are normalized. And then our last example is the distribution of 1,000 random numbers that were generated between 0 and 1. And what we notice as we look across the bars is they're all pretty much the same height. So this is a uniform histogram. And what it means is that the data in each interval is similar, or even the data across the board is similar. Now, what you might notice is that on all three of these histograms, if you look at the bottom of the histogram, you don't see an interval, you just see numbers. So actually our first histogram showed intervals, if you look at the top of the screen, 0 to 5, 6 to 11. But the last two only showed a single number. They're still displaying intervals, and what it means is, so for example, looking right here, what it typically means is that it includes the left endpoint, but not the right, because you can't have the data value of 65 in two different bars. So in our first grouping here, it's actually the data from 60 to 64 feet. And then the second grouping would be from 65 to 69 feet. So it includes the left endpoint, but not the right, and the same for the bottom histogram. All right, so the last thing we're going to do is learn how to create a comparison histogram. And I started by filling out the frequency tables. I did spend a little bit of time trying to find a good interval that would show the detail of the data, but not end up with 15 to 20 bars, because in a case where you only have I think we've got 12 data values in each group, it doesn't make sense to have 15 bars, because you wouldn't have 15 bars, you've only got 12 data values. So I thought about grouping in groups of 5, and that ended up with, I think, 3 or 4 bars, and that just didn't seem to show enough detail. So I ended up grouping by 3s instead. What you need to do when you're deciding on an interval is make sure that the intervals are the same amount. So if you look through my grouping, 8 to 10, 11 to 13, they all include 3 different hours, and they're not varied with how we group them. And then what we do in our second column is we chart the frequency. So I just like to use a tally chart. So 12 would fall in the interval 11 to 13. 9 goes in my first interval. I've got 4 10s, 14, 11, 18, 21, another 14, and 22. All right, so for my second grouping, same thing, 13, 15s, 12, 10 and 8 are in the same group, 25, 17 and 16, 14, 18, and 11. So now that we have our frequency set, we are going to display that on the bar graph at the bottom. So what I'm going to do is I'm going to call brand 2 my blue bars, and we'll make a key for our histogram. I'm going to start by charting brand 1. So my first grouping had a frequency of 5. Actually, now that I look, I have brand 2 split up first. So I'm going to start with a frequency of 2. And again, I had my histogram set up just to save us some time. So I created the groupings on the bottom. And what you want is you want all of your bars to be about the same width. So you really want to be careful. If one bar is fatter than another, it's going to look like it has more data, even if it doesn't. So my first one on the red side had 5, so I'm just going to go up to 5 here. And then looking at my blue one, my brand 2, my next group had a frequency of 3. And then my red brand, the 11 to 13, had a frequency of 2. And on my blue brand, 14 to 16 had a frequency of 4. And my red brand, 14 to 16, had a frequency of 2. And that bar did get a little bit fatter than the other ones. My blue brand, 17 to 19, had a frequency of 2. And 17 to 19 for my red brand had a frequency of 1. And 20 to 22 was empty on the blue brand, so on the red brand it had a frequency of 2. And my 23 to 25 had a frequency of 1 for my blue brand and 0 for my red brand. So what I would probably do to clarify the data a bit more is actually shade the bars blue or red, because right now it's a little hard to look at. But to save time, I'm just going to go ahead and make my key. And I would say my blue bar is brand 2. And my red bar is brand 1. And I have my histogram with a title, battery life. I have my x-axis labeled hours. And I have my y-axis labeled frequency, so make sure you get all of those things on your histogram. And finally, we're going to compare our histogram and make a recommendation as to which battery we think would be the better buy for your money. So as I look through my red bars, my highest red bar is in the lowest grouping, 8 to 10 hours of battery life. And then my blue bar has the highest bar from 14 to 16 hours. So just kind of looking at the mode, or where the majority of the batteries have their longest life, I would probably recommend brand 2.